Hello, this is Jordan with the practice set, and today we're going to learn how to do a Calculus 3 problem involving Lagrange multipliers. So let's get down to this. Find the extreme values of the function f of x and y is equal to x squared plus 4y squared on the circle x squared plus y squared equals 4. So what we're trying to find here is the extreme values of this function given the constraint of this function. And the way that we do that is with Lagrange multipliers. So what this involves is we have to take the partial derivatives of this function and set them equal to lambda times the corresponding partial derivatives of this function. So as we see right here, we get 2x, which is the x derivative of our f function, and we set it equal to lambda times the corresponding derivative, the x partial derivative of our constraint equation, which gives us lambda 2x. We do the same for the y. The y partial derivative is 8y, and we set that equal to lambda times the partial derivative of this, which is 2y. It gives us lambda 2y, and then we add in our constraint equation. Those are our three equations. Now we just do the basic algebra to solve for the variables. Now, because this is a complex system of equations, we can have more than one value for a certain variable. So we have to take that into account. The first thing we're going to do is we're going to solve for lambda. That's going to be the first variable we solve for using the x equation. So this is very simple because the two x's are the same. Lambda is equal to 1. We plug that into the y equation to give us y equals 0. And then we plug the y into the constraint equation to give us x is equal to plus or minus 2. Now, as I said before, these variables can have more than one value. So we solve for lambda using the x equation. But if we use the y equation, then we'll get a completely different lambda, which we have to account for. So we're going to do another system of equations to solve for the lambda using the y equation. So we plug that in right there. We do the basic algebra, but we have two variables. So we get values of y can either equal 0 or lambda can equal 4. But if we look at our system above that we already solved for the first time, y is already equal to 0. So we don't even need to account for that. And we can just solve using lambda equals 4. So we plug that into the x equation, and it gives us x equals 0, which we then plug into the constraint equation to give us y is equal to plus or minus 2. Which means that if we go through both coordinates in both systems, we have plus or minus 2, 0, and 0 plus or minus 2. And these are our extreme values. Now, to find the min, now we have to find the extreme values, which is merely the min and max points. And what we do for that is we plug in the values that we got into the given equation, our f equation right here, f of x, y equals x squared plus 4y squared. So we plug those values in, and we see that we get 4, 4, 16, and 16. So because we have two values that are our min and two values that are our max, we account for both of them by saying that our minimum is 4, the value of 4 at the coordinates plus or minus 2, because x equaling plus or minus 2 gives us the same value, and our maximum is 16 at the coordinate 0 plus or minus 2, because y can be either positive or negative to give us that value. Well, I hope that you learned a lot from looking through this problem. You should check out thepracticeset.com, where we do a multitude of problems that are just like this, solved out step by step for you to learn them very easily. We have a link in the description, and we hope to see you there. All right, bye-bye.